Okay, next, geometry sequence is a sequence in which each term is produced by product of a fixed number. Means you have a first term, then you have second term, you have your third term. Here you will multiply a value. So multiply a value. So that fixed value we call it common ratio because you multiply. Multiply is a ratio. If you plus minus is difference. Common difference. So arithmetic we use common difference, geometry we use common ratio. So A still stands for first term. And then for geometry sequence, we still have its formula where Tn equals to ARn minus 1. So sum of the n terms. Alright, we have two formula here where your R is less than 1, we use this. Where your R is more than 1, we will use Rn minus 1 over R minus 1. Alright, so take the notes down. And then we have sum to infinity. It will be equal to A over 1 minus R. So why we having our two formula on this sum of first term? When your R is less than 1, means like 1 over 2, 1 over 3, so that your 1 minus R will not be negative. Alright, so your R is greater than 1, then when you minus 1, it will not be negative. Alright, so for example 9, sequence 3, 6, 12, and 24. 5 is n term, and then the sum of the first 5 terms. So for this, we have to identify is it arithmetic or geometry. Arithmetic or geometry. So because this question doesn't mention for you arithmetic or geometry, so we have to prove it. We have to validate first geometry or arithmetic. So if geometry, the common ratio will come from the term behind divided by the term before it. Term yang selepas tu tolak yang sebelum. So you try to prove it, is it having the same R? 6 divided by 3, 2, right? Another 12 divided by 6 is also 2. So this sequence is having common ratio, which is 2. So this is a geometric sequence. So after we prove this is geometric sequence, then only we can answer what's your Tn. A is 3. So Tn will be Arn minus 1, where A is 3, R is 2, n minus 1. So it becomes our indices. Your indices here. So simplify these indices, we can get 2 to the power of n times 2 to the power of negative 1. So take your number 3 times 2 to the power of negative 1, it will be 3 over 2. So it involving your chapter 2 basic again, indices concept. So after that, we have to find sum of the first 5 terms. Sum of the first 5 terms is S5. So you can see our R is greater than 1. Our formula, it will be using A, Rn minus 1 over R minus 1. Alright, then we plug in our first term 3. Common difference 2. Power of n, which is 5. So 2 minus 1. So this one you can simplify using calculator.